Yo, 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 yo. All right, guys. So we're going to be factoring quadratics, but now we're going to focus on factoring quadratics that have an A term, or an A value for A here. So before, if you haven't watched 7.5 Factoring Quadratics Part 1, make sure you do that first, because I'm assuming that you know how to do those at this point. Okay, so you have to know how to do those in order to be successful here. So we're going to factor quadratics and now have a value here for A. And so our rules are going to change first. So first thing we're going to look at is, do they have a greatest common factor that I can just factor out regularly and then get rid of that A term? So if I look at this, I have 3x to the third power plus 15x squared minus 18x. Well, I'm looking at the values in the front, the coefficients, and I'm trying to determine, do these have a common factor? Well, they do, and it's 3. So if I can factor out that A term, let's just do that first. So I can factor out a 3x, because this is cubic, it's not even a quadratic. And if I factor out a 3x, that's going to become x squared. Let's see, this is going to be plus 5x, because I'm just pulling out a 3x from all of these, right? Dividing all of these by 3x, by 3x. Okay, and then this is going to become minus 6. Now I can factor this like normal. What are my factors of negative 6? That get me to positive 5. So once I do that, that's going to give me x plus 6, x minus 1. And I'm done. Now notice I don't have extra parentheses or anything. It's just this 3x is on the outside. There's nothing else to do. We are all done. So first, just determine, can I factor out a greatest common factor? If we can do that first, and then do it. So try this one on your own real quick. So try to factor this out first. So hopefully you're done. The greatest common factor, it is 6x. So I can pull 6x out of all of these. So when I pull out 6x, I'm left with x squared plus 5x, and this is plus 4. Well, now I got to factor out this quadratic, which is going to be x plus 4, x plus 1. So I'm done there. Now let's look at the ones though where they don't have a greatest common factor for me to take out. So we're going to show two different methods for this. First, I'm going to show you factor by grouping. Okay, so here are the steps. And you have this in your notes, so it kind of walks you through. Yes, there's a few steps here, but I'm going to show you how to factor by grouping first, and then we'll show you a different method called slide and divide. So right now I can't factor out a 6 because none of these are divisible by 6. So what I need to do is I can't just find the factors of 4 that add up to 11. That doesn't exist. So what we're going to do is we're going to follow these steps. So first thing we're going to do for factoring by grouping is we're going to multiply A and C. So I'm going to multiply 6 times 4. Well, 6 times 4 is 24. So what I'm actually looking for are factors of 24 that are going to add up to 11. So very similar to what we did before. Before I would have found factors of 4, but instead of finding factors of 4, I'm finding factors of 24 that add up to 11. Well, the factors of 24 that add up to 11 are going to be 8 and 3. So what I'm going to do is I'm going to take this 11x and I'm going to split it up into 8x plus 3x. So I didn't change the value here. Okay, so what I did is I just took this 11x and I rewrote it into two different terms. 8x plus 3x, if I wanted to simplify this, it does make 11x. So, and the reason why I'm doing that is because those are the factors that add up to A times C, or those are the factors that add up to 24. So I'm going to rewrite all of this. And so all I did was I split this 11 up. Now what I'm going to do is I'm going to group these up with the two monomials on the left. I'm splitting this up into two different binomials. So I got the binomial on the left, I got the binomial on the right. I'm actually going to move all of this over for a second here, just so I have space. There we go. So I have this binomial and I have this binomial. Okay, so right now this is step 4. I grouped as two binomials. What I'm going to do is I'm going to factor out the greatest common factor from just this only binomial. So the greatest common factor here is 2x, because they both have an x in common, and I can factor 2 out. So if I factor out a 2x here, this is going to become 3x plus 4. Now I look, can I factor anything out of here? And this is not factorable, this is prime. So this is also 3x plus 4. If we do this right, do we notice how these are the same? Okay, these are the same thing. So what we're going to do now is, because these are the same, this is one of my two binomials for my final answer. My final grouped answer is going to be 3x plus 4, and that's going to be times another binomial. Well, the other binomial are the GCFs that I factored out. Well, the GCF for 3x plus 4 is 1, right? Because I could technically factor out a 1. So when you can't factor out its prime, we do still want to factor out that 1, because what I'm going to do now is I'm going to take the values on the outside that I factored out, and those are going to make my second binomial. I'm done. This is my final answer. If I were to distribute this out, it should get me to 6x squared plus 11x plus 4. 4 times 1 is 4, so that's good. And then 3x, 2x gives me 6x squared. 3x plus 1x is 3x. 4 times 2x is 8x, which gets me to 11x. So there's a lot going on here. It takes a little bit of practice. So let's look at another one. I'll move this towards the middle. So I'm going to factor by grouping. So the first thing I need to do is I need to take the a value and I need to multiply it by c. So I'm looking for factors of 30. I'm just going to write off 30 to the side because 10 times 3 is 30. So I need the factors of 30 that are going to add up to 17. Well, that's 15 and 2. So that means I'm splitting up 17x into 15x plus 2x. That's 10x squared plus 3 on the end. So this is the same thing. Like, I haven't changed anything. I just rewrote it a little bit differently. Well, now we group it into two different binomials. And I got to factor out the greatest common factor of both of these. Well, greatest common factor here is 5x. So if I take out a 5x, I'm left with, let's see here, this is going to be 2x plus 3. This doesn't have a greatest common factor, so we'll take out a 1 and keep it as 2x plus 3. And again, if we do this right, these are going to be the exact same thing. So this is 2x plus 3, 2x plus 3. So I'm left with 5x plus 1 and 2x plus 3. And we're all done. Here's the 5x plus 1. Here's the 2x plus 3, just comes down here. Because really what I'm doing is I'm factoring out a 2x plus 3 from both sides here. I'm factoring out a 2x plus 3 from everything, and that's why I'm able to go this route. Okay, so that was one method. Now we're going to learn slide and divide. So slide and divide is just different, okay? It gets us to the same result though, okay? So for slide and divide, the first thing we're going to do is it's in some ways similar, but it's still different. It's definitely different. So the first step is still the same. We're going to slide. We call this the slide, where I take 3 and I multiply it by -8, and I'm going to rewrite it. So this is similar to our first step that we did here, where we multiplied a and c, but we wrote it off to the side. Now what I'm going to do is I'm actually sliding this 3 over here, and I'm rewriting it without the 3. So this is x squared minus 2x, and this is going to be minus 24, because 3 times -8 is -24. So I rewrote it by sliding this over here and multiplying. So this is now what I'm going to factor. I'm going to factor this like normal. I'm looking for factors of -24 that are going to get me to -2. So now we actually follow our original steps that we learned from factoring. So I want to split this up into two binomials. Factors of 24 that are going to get -24 that are going to get me to -2. Well, I know 6 times 4 is 24, 6 minus 4 is 2. So it's going to be -6 plus 4. I know it's -6 because when I combine -6 and +4, I will get -2. But this is obviously not my final answer, because if I multiply this, I will not get here. Okay, we did change it. Like, we changed the value here. These are not two equivalent things, and that's okay, because this is all part of the step. So now once I factored, and I've got my two binomials, what I have to do is I now have to, because I multiplied by 3, I have to now divide by 3 to make them back to equivalent. I have to undo what I did in the beginning. But what I'm going to divide by 3 are the two coefficients here. or I'm sorry, the two constants, not coefficients. I'm dividing the two constants by 3, because that was the number that I multiplied. So I'm just dividing it. Well, now I simplify these two values. So I'm going to do x minus, well, 6 over 3 is 2, so that's going to be x minus 2. And then I can't simplify this. Like, I can't simplify 4 over 3. So because once I can't simplify, that becomes our coefficient. And that's 3x plus 4. I'm done. So I get x minus 2, 3x plus 4, and when I multiply those out, it should work out to 3x squared minus 2x minus 8. So I slide over by multiplying, kind of like what we did in the first steps, but now when I rewrite it, I just factor like normal, but then I just got to divide by whatever I multiplied initially. If I can simplify it, simplify it. Okay? And then if I can't simplify it, whatever that is remaining in the denominator becomes your new coefficient of x. And then you're done. Let's look at this first one here. Is that? Oh, it's not. Okay. Let's look at this first one here. I want to try this one with slide and divide again. Show you another example of slide and divide. So first step, slide this over by multiplying and then rewrite. X squared minus x minus 12. Now I factor like normal, so I'm looking at my factors of negative 12 that add up to negative x, or negative 1 I should say. So that's going to be negative 4, positive 3. This is going to, negative 4 times negative 3 times positive 3 is negative 12. Negative 4 plus 3 is negative 1. But now because I slid over the 2, I got to divide everything by 2. This simplifies to x minus 2. This does not simplify, so I got to bring this back up front. So that's 2x plus 3. And I'm done. Okay, I want you to try this one on your own and choose whichever method you want to try. So if you want to try factoring by grouping, try that. If you want to try slide and divide, try that. Okay, there's no one that's better than the other. It's just, at this point, it's kind of personal preference and whatever you think is going to be the most useful for you. Okay, so I'm going to use slide and divide. So I'm going to slide this over, so that's going to give me x squared plus 3x minus 10. So then now that I'm at minus 10, I'm looking for factors of minus 10. They give me the 3. It's going to give me x positive 5, x minus 2. Now I got to divide everything by 10. So this is a good one here. So here, this is a good example to show you what to do. So I still got to simplify this. So that becomes x plus 1/2. And this becomes x minus 1/5. I'm simplifying these two fractions. They still simplify it as fractions though. Like I can't get a whole number here. So because I can't get a whole number, both of these go out in front. So that's going to be 2x plus 1. And that's going to be 5x minus 1. So if you ever have a denominator left over, no matter what the fraction looks like, if it's an improper, if it's a fraction like this, we always simplify, and whatever the denominator is still becomes your new coefficient. I'm done. If you did factor by grouping, then you still should have gotten to the same thing. Okay, so we have a right rectangular prism. Here's its volume. We want to find the expression for the length, the width, and the height, and then we want to know what is the least possible integer value for x for the rectangular solid to exist. So go ahead, we've done ones like this before, so pause it, try it, and see how you do. Okay, so I cannot factor out 6, because 6 cannot be factored out of 3 or 45, but I can factor out a 3x, like that'll work. All of these are divisible by 3. So if I factor out 3x, that's going to give me 2x squared, because I'm factoring out a 3x, right? So factoring out a 3x from all of these. That's going to give me 2x squared. That's going to give me minus x. And that's going to give me minus 15. Now I got to factor out this 2x squared minus 15. I got to factor out 2x squared minus x minus 15. Okay, so now I got to either choose factor by grouping, or I have to choose slide and divide. Okay, so what I could do is for this one, I'll do factor by grouping because the last one I did slide and divide. So if I'm going to factor this by grouping, I'm looking at 2 times negative 15 is negative 30, and I want factors of negative 30 that give me negative 1. Well, that's going to give me negative 6 and 5. So I got to split this up into negative 6x, positive 5x. All right. So I rewrite it. Now I've got my groups. And now I got to take out the greatest common factor. Well, from here it's going to be 2x. So that's going to give me x minus 3. And then from this one, I'm going to factor out a 5. And that's also going to give me x minus 3. Well, now I can take out this x minus 3 here. So there's x minus 3, 2x plus 5. So my expressions for the length, width, and the height, the length are 3x, x minus 3, and 2x plus 5. So those are my 3 dimensions, because don't forget about that 3x that we took out in the beginning. Now what it says for the second part is what is the least possible integer value for x for the rectangular solid to exist. So it's saying integer value. So I got to find what's the smallest integer so that for this to exist. For this to exist, everything has to be at least greater than 0, right? So if I look here, for anything to be greater than 0 here, x has to be at least 1. And that's on this one. So that's 1's a possibility, but 1 wouldn't work here, because if I plugged in 1 here, this would be negative. And so 1's not going to work. So now, for this one, it'd have to be 4, because 4 minus 3 is 1. So x times 4 works here, and does x equal, for x is 4, would that work here as well? Well, let's see here. 2 times 4 is 8, plus 5 is 13, so 4 works. Because 4 is the smallest I can have that would work for this value right here. So the answer is 4. Okay, so that is it. For things to remember, there's a lot to remember here. So I'm actually not going to put anything here. But for independent practice, try this out. Remember, this is a -1. That is not the same thing as +1. So this would fall under factor by grouping or slide and divide. And then that's it, guys. So I hope this helped. If you have any questions, you got to let me know. Good DS out.